Let me start out in this class by asking you guys a question. I want to find out the average number of hours everybody in Bethlehem sleeps. What problems am I going to run into? Everybody in the town of Bethlehem. I want to know on average how many hours of sleep they get a night. But you know what problem? One big problem I'm going to run into right away. Am I going to get everyone? That's not possible, right? We talked about that. I'm not going to get the full population, so I take a smaller piece, which is called my what? Sample. So here's the next problem we're going to run into today is if I'm just going to take a portion of Bethlehem, am I really going to get the true average? No, right? Because I'm not doing everyone. I'm not going to get this true average. But I'll be hopefully if I get a good sample, I'll be in the ballpark. Okay, so that's what I'm going to show you today is we may not get because the population is so large, I may not get the true average, but I can at least be in the ballpark and be pretty close to the average. All right, and this is how we're going to start today off of. I'd like everyone to introduce you to my mystery bag. Okay, as you can hear, it's got chips in there. It's got some black and some red chips in there. How could we determine without looking in and obviously dumping them out and counting them, how many red chips are in my bag out of 20? Any thoughts, theories on how I could find out about how many red chips are in this bag? Any thoughts before I give you the way we're going to do it? Hi, JT. Okay, I didn't think that one, but you could ask me, yes, because I do know the answer. True. Yes. All right. Any other ways that we could do this? Hi, Dom. So I could take a handful out and say, all right, these are how many are red. You know, compare that to the whole thing of 20 and say, all right, I like that. All right, that's a nice way. We're going to do a little differently, though. Here's what we're going to do, everyone. I know I don't have 30 of you. How many do I have? 2, 4, 6, 8, 10, 12, 13. Okay, so some people are going to pick more than twice. I'm going to pass the mystery bag around. You are not going to look inside. All you are going to do is ruffle around, take out a chip. We'll record if it's red or black. You're going to put it back in. I want to do that 30 times. Okay, I'm going to do that 30 times, and then we'll see if we can make a prediction on how many reds we actually think are in here. Okay? All right, so here we go, everyone. I'm just going to pass the old bag around. We're going to tally up how many reds there are, and then we'll talk. Just don't look into the bag. Pull one out, show it to everybody. We'll record it, put it in the bag. Red. Just going to do a tally mark. Red. 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 I do that to you, all red. Black. Yep, put it back in, ruffle around. Red. We got to go 30 of these, so let's get it moving. Red. Put your paw in there, Ian. Let's go. Oh, black. Put it back in there. You're going to throw off my numbers. Red. This is fun. Red. Oh, red. There's a shocker. Black. Red. We're only up to 12. Let's get this moving. Red. Red. A way to start off today. Oh, Mary with the black. All right. Red. Black. All right, another, wow, 2 in a row. Red. 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 9 more. Red. Oh, we got a red. Got a red. What'd you have? Whoa, black. All right. A red. What are we up to here? 26, right? Black. Oh boy, yikes. Red. We got one more. One more draw. Can she go 3 in a row? Okay, here we go. So I won't reveal yet how many reds are actually in there, but based on what we just did, how can we predict what we think how many reds are there? Well, how many times did we choose? 30. How many reds came up? How many? So 20 out of the 30 reds, right? So not 30 reds, but 20 out of the 30 picks were reds. What percent is that? What percent of reds did we pick out? About 66%. I'll round it to 67%. And how many chips are in the bag? So shouldn't we predict about 67% of these chips should be red based on what we did, right? All right. So what's 60% of 20? 67% of 20. About 13. So that's our prediction right here, 13 chips. 13 chips. Okay. I'll save the suspense for a minute. Is there any way we could get closer to actually how many there are in? We did this how many times? If you think we went around another 30, which I'm not because my head might explode. If we went around another 30 times, you think we'd get closer to actually how many are in that bag? Yeah. All right. So how does the number of samples we did affect our guess? The more samples, what happens the more we do it? The closer we get to the actual number. Actual amount of red chips. And we knew that from the probability unit. The more you do, the closer you get. Ready to see how many chips are red chips? That's it. How many red chips? 15 red chips. Okay. Now, were we in the ballpark? Sure. Why didn't we hit the number exactly? How many times did we do this? 30, but we were in the ballpark at least. All right. And what I want to show you today is how do we get into that ballpark? All right, without having to pick chips out of a random mystery bag. All right, mathematically, how do we get to it? So in the next example, who do we have? Tanya and Ron, good friends. Okay, good friends, Tanya and Ron. They did this. They did this mystery bag thing, but I guess they had a lot of time on their hands because when we went around once, they went around 50 times. So they picked 30. Here you go, ready? Here's what they did so you understand what's going on in this problem. They picked 30. They said, okay, I had 13 red chips, so they marked a dot at 13. And they go, let's do this again. And they counted how many red chips. They put another dot, and they did that 50 times. This right here I want to introduce you to because you're going to be seeing a lot of it. That's called a dot plot. Okay, dot plot. So think about it this way. Whatever 15 times 30 is, that's how many chips they picked. Okay, that's how many chips overall they picked. So let's look at their dot plot right now and answer some questions on it. What's the most common number of red chips in their 50 samples? Should be 10. Does this seem reasonable that they got 10 as the most? Look at the dot plot. I'm not talking about picking out of the bag anymore. Just based on all their other results, is 10 a reasonable amount to come up the most? Based on where all their other dots are. Yes, no? What would be unreasonable if they got the most amount of 25? Because everyone see that's not even close to the majority of the other dots. All right, so does everyone see 10 is reasonable because it's around all of the other samples? Yes, no? I got to take this slow because this is when it gets crazy, the second half of the stats unit. So it is reasonable because they are around the other samples. Because 10 is around the other samples. Again, guys, you start putting here you go. You start putting dots at only one, something's up. I'm not believing that. Something's up. Okay, but because 10's around the majority of them, I'm good with that. All right, speaking of odd occurrences, what numbers never occurred? What number of red chips never occurred in the sample? 0 to 5. Wait, hold on. 0, it can go more than 5, right? That's 9, 8, 7, 0 to 6. What else never occurred? What do we got here? 16, 17, 18. So 19 to 30. Could you give me an interval you're confident the number of red chips fell in? All right, that mystery bag that they pulled from. Could you give me a small interval, a big interval, I don't care, that you're confident that hey, that's the number of red chips that are in there between this and this number? And it could be anything here. There's not one right answer I'm looking for. Could you give me a confident interval where you're saying, I'm pretty confident this is the number of red chips that are in there? From what to what?
10 to 13.
Okay, that's fine. 10 to 13. Give me another one you're confident in. Probably, do I want 20 to 30? No, we're not confident at all. Do I want 1 to 5? No. What else? Give me another one you're pretty confident in. It's probably, can't go. 7 to 18. That's a huge one, right? That's a huge interval. Any others? Throw one more out. Why not, kiddos? I got that. How about another one, Mike? One job. Okay, 15 to 18. I don't know how confident I'd be there for 15 to 18. Okay, how about 10 to 14? I like that one. This right here, these intervals you're giving me, guys, here's what we're going to refer to that for the remainder of the unit. That's a confidence interval. Confidence interval. The interval which you are pretty confident the average is located. And today I'm going to show you how to find that interval mathematically now instead of just random guesses. All right, mathematically. All right, and honestly, cross off D. There's some stuff here that we don't have to go as far. All right, so now let's not worry about it. All right. He's ready. 2 terms I want to introduce you to today: margin of error and confidence interval. Quick question, hopefully you have. You've probably seen these on the news, maybe in the newspaper. When somebody does a poll and they report the results back, do you ever see this number down here at the bottom? That plus or minus something. Have you ever seen that, took notice of it? No, really? Stop it. Nobody? There's always anytime somebody goes out and does a poll, they come back and say there's a plus minus there. You could, but that's usually what it went up or down the stock. Okay. What this number represents when you do the polls. Hi, JT.
It's like a range, like acceptable values.
Yes. This is what's referred to as the margin of error. Do you see how 41% said yes? Do you think exactly 41% said yes? No, that's impossible. There's too big of a sample to test. That doesn't mean exactly 41% said yes. So this is why they have this plus or minus 3.8%. Here's what that means. It's not exactly 41, but I bet you it could be anywhere from 3.8 above or 3.8 below. So if you guys do 41%, go ahead, 41 in your calculator right now, add 3.8 for me. What do you end up with? Well, there was like 10 different voices, and I think they all said different things. 44.8 and do 41 minus 3.8. 37.2. So here's what they're saying by putting this, what's called margin of error is, you know what, 41%, probably exactly 41%, no, but I bet it's between 37.2 and 44.8. We're pretty confident there using that margin of error. Okay, so that's what that means. It could be above that or below that, the average. We all good? Okay, so how mathematically can you get this number, the margin of error? Ready? It's a formula. I know another one you have to remember. Margin of error is equal to, here's how we're going to find it. You're going to do plus or minus 2 times the standard deviation. Plus or minus 2 times the standard deviation. That's how we're going to find out how off, above or below we are from the mean. So everyone go ahead to this first example. It says find the confidence interval, which I'll go over in a second, and the margin of error for this following dot plot. Okay, so my margin of error, plus or minus 2 times, anybody, I give you the standard deviation in that one, right? 0.046. So go ahead, 2 times 0.046. You end up with 0.019. I should get my notes, but I don't feel like getting them. 0.092. What does that mean? Whatever the average is, the mean here is, we could be off by 0.092 and to the right or 0.092 to the left. That interval, it's called the confidence interval. I get it from using my margin of error. The confidence interval, which I'll abbreviate as CI, is going to be taking your mean and adding and subtracting that margin of error we just produced. So when Mike told me 10 to 14, this is how we mathematically find that now. Okay, so here we go, everyone. What was the mean in this dot plot? 0.502. Plus or minus 0.092. So everyone go to their calcs, add 0.092 and subtract 0.092, and we'll find that interval. So when you guys subtracted it, what did we end up getting? 0.410, right? Or just 41? And when we added 0.092 to the mean, what did we end up with? 0.594. Guys, we are confident that the mean of this data falls between these two numbers somewhere. And ready for this one? How confident? We always assume 95% confidence. Okay? So we are 95% confident the actual mean falls between these two numbers. All right? And hey, guys, look at the interval and look at the dot plot. 0.41 to 0.594 aren't a majority of them within there. Yeah, you're darn right. All right, so we're pretty confident somewhere in there is the mean. Questions? Can you find the next one? Should we do it together or on your own? What do we think here? You guys usually tell me straight what you think. I just want to go ahead, find the margin of error, and then find your confidence interval. This is the proportion of people who spent at least 15 hours studying. What are you guys getting as the margin of error? Plus or minus 0.038, so that's how much we're off by. And then the confidence interval, I take the mean, 0.4504, add and subtract the margin of error. So where's going to be my 95% confidence interval? 0.4124 to 0.4884. And that is where a majority of those points are on that dot plot. I got a challenge question for you. The margin of error, that number we're getting, 0.038, do you think it would get bigger or smaller if I increase the number of people I sample? Or correct. All right, the people I sample, the closer I get to the mean. All right, good, good, good. Any questions with those kids? Anything at all? Because you know what? We're going to have a lot of fun right now because we're going to make our own dot plot. Yes, Don, our own dot plot. I know. Look at you. You're so excited. Our own dot plot, everyone. All right, flip it over. A class of 28 juniors. Wow. Wanted to estimate the proportion of all juniors and seniors at their high school with part-time jobs. And just so you, hey, before we do anything, I do want you to realize how these numbers, like what these numbers represent. In this specific example, if we were this class that did it, here's what I would do. Ready? Hakan, go out and go sample 30 juniors and seniors. He would come back and say, out of the 30 I sampled, 15 had part-time jobs. So I would write down 0.5. 15 out of 30, 0.5. Gabe, get out there and do 30 juniors and seniors. He comes back, hey, 22 out of the 30. So I do 22 divided by 30, whatever that decimal is. That's what these numbers are, guys. All right, you can think of them as percents. All right, what percent out of the 30 have part-time jobs? All right, our dot plot. Here we go, our own dot plot. Okay, so I got my horizontal line going to put the values on first. Now, what should go on there? Numbers, preferably ones that correspond to the proportions I give you. So can we figure out where the high and the low one is? What's the highest and lowest proportion here? The lowest one, point 0.4. Anything lower than 0.4? Okay, so can we start it at 0.4? Sure. Can we start it at 0.35, 0.3? As long as 0.4 is represented somewhere. And what are we going up to? 0.8? Okay, now let's make a decision again. Do we want to all go by ones? Probably not. What can we go by here? I guess we can go by twos.
Yeah, let's just do that.
You want to go twos? Mary with the fives.
That's a little extreme because
I'm going fives. But again, you can go whatever you heart's desire. And can I ask you a question and be honest with me? Before we start putting dots where they need to go, would this be less stressful on you if they were all in order? And you could just go right through and it would be? Okay, am I going to do that for you? No. But your calculator will. I don't know. That's a great question. I don't know if it can or not. I've never looked into that. But your calculator will sort them for you. Now, this is an option. I'm not requiring you to do this. If you can, if you feel comfortable doing 0.7, 0.8, dot, 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 all the way around, that's fine. All right, but I'm going to show you how to put your numbers into order. First of all, where do you think I got to put all these numbers? Where have we put numbers all unit long? Into a list. Yep, so go ahead. Type those bad boys into a list. Stop. So put them into a list, and I'll show you how to sort them. Make sure the last one you're typing it into says 28 at the end there. It should say L1 parenthesis 28 because there's 28 of these. Well, here we go.
how many times a day do you do
I haven't heard one in a couple weeks actually, but luckily they stop right away. I'll wait till everyone has them typed in. Well, are you about to enter your 29th one?
Oh, wait.
The last one should be 28 that you filled in for, so that's fine. How are we doing? Can we go? Okay, let me know. Good, yes, no? Go back to stat. Go back to stat. Do you see right underneath the word edit, you have sort? There are two sorts, sort A and sort D. Sort A stands for ascending, which means lowest to highest. And D stands for descending, which means highest to lowest. I assume we want lowest to highest. So choose number 2, sort A. And then it's going to ask you, what list would you like to sort? That's what it's asking for right now. So whatever list you put it in, L1, so you go second 1, L2, second 2, type it in, and press enter. It'll say, hi, I'm done. Everyone's calculator telling them they're done. Go back to your list under stat edit, and look at that magic. Everyone go back to your list, stat edit, and it's all, look at that. Get it, get it. How's our plots look? Looking good? Everyone good with their plots? So we can answer these last two questions together. Based on the dot plot now, do you think all juniors with part-time jobs could be 0.7? Do you think it could be 0.7? Could it be 0.7? Yeah, it could be. Why? A majority of the don't look at just 0.7, look at everything around it. All right. Yeah, it could be 0.7 because a majority of the other samples are around it. So yes for 0.7. Because majority of the samples are near it. What about 0.5? This next question. What about 0.5? Do you think it probably could be 0.5? See the difference? Even though there's nothing at 0.5, that's not why I'm saying no. I'm saying no to 0.5 because none of them, basically, I got maybe like 1, 2 of them around there. That's not good enough for me. All right, it's got to be a majority of them. All right, so no to 0.5 could not be because not the majority of the samples are not around it. Okay. How many did I ask Hakan and Gabe to go out and get? How many people in this problem? It told me to go out and get 30. What if I told them to go out and get 60? How's my dot plot going to change? Because it will change. What do you think will be the effect of my dot plot if I have all of you go out and do 60 instead of 30 now? Yep, these points are going to get closer together. Correct. All right. So if I go from a sample size of 30 to 60, how would the distribution be different than that of 30? Our dots would be closer together. And what if I said, you know what, let's do 15 instead? Now what would it look like if I just did 15 instead of 30? Wider, spread out. It'll be more spread out, okay? Because remember, the more we do, the closer we get to the actual mean. All right, just skip number 2 on the homework. All right, cross off number 2. We don't need to go that far where I give you the interval and you give me the margin of error. So go ahead. You got plenty of time to get most of this done. How's the yoga going? Good? You've been doing that all semester, it seems. Yeah?